This is IB Chemistry, uh, Chapter 4, Chemical Bonding. Okay, now on this video, I want to explain on orbital overlap and hybridization. So before I go further on the hybridization, I want to explain what is the relationship between periodic table and orbitals. Okay, so this is my predictables. Okay, as we knows that every column represents the number of group. So from left, this is group one, group two, and at the middle is transition element, and then continue to the group 13, group 14, group 15, 16, 17, and group 18. Okay, in IB syllabus, group 13 also refer as a group 3. Group 14 refer as group 4, 15, 5, 16, 6, 17, 7. Okay, and every rows represent the number of period or number of shell for the atom. So from left, from the top, period 1, period 2, period 3, period 4, period 5, 6, and 7. Okay, now what is the relationship between periodic tables and orbital? Okay, look at the group 1 and group 2. Okay, all elements are located in group 1 and group 2. Okay, group 1 and group 2. Okay, this element have s orbital. Okay, this is represents the valence orbital for each atom. Okay. Example, lithium. Lithium have one s one, one s two, two s one. So this is location for lithium. And I write down on the predictable 2s1. So in predictable also same as the position of element in predictable also same as the valence orbital for the element. Okay, just refer on the valence. Okay, so lithium 2s1. So this is the position of lithium 2s1. What is mean by 2? 2 is energy level. Okay, energy level, or in other words, we call it period. Okay, 1 here shows the number of electron. Okay, S is the orbital. Okay, now, for the transition element, all the transition element have d orbital. D orbital. Okay, the orbital. So from left, it start with D1, D2, D3, D4, D5, D6 until D10. Okay, and when going down the group, the number of energy level is increased from 4D, 5D, 6D, 7D. Okay, now where is p orbital? Okay, p orbital are from group 13 until group 18. Okay, except helium. Okay, except helium. Helium have one s2. Other than that, group 13 until group 18 have p orbital. So from left, p1, p2, p3, p4, p5, and p6. All group 18 element except helium have p6. This is octet. Okay, so this is already octet. Okay, so this is the relationship predictable and orbital. Now, what is mean by the orbital? Okay, so this is the element with s orbital. Okay, as we know from group 1 and group 2. Okay, so what is the diagram for s orbital? Okay, s orbital. S orbital example, hydrogen. Hydrogen F1s. Okay, and then this is the orbital diagram for hydrogen. Okay, all elements that have s orbital have this shape. Okay, I draw 3D dimension. To draw 3D dimension, I have to draw the graph first. Okay, Z. And all s orbital have sphere shape. Have sphere shape. Okay, and each orbital have the maximum number of electron 2. Okay, maximum number of electron 2. So if hydrogen F has one electron, so it just have one electron. Okay, upward. For sodium, okay, just look at the valence orbital. Okay, this is valence orbital. Okay, and sodium have 1s2, 2s2, 2p6, and 3s1 electron configuration. Okay, so we just refer on the valence orbital 3s1. So 3s1, okay, meaning that it has sphere shape. Okay, sphere shape, and it have one electron. So inside this orbital have only one electron. Okay, for the calcium, okay, calcium have 4s valence orbital. Valence orbital. Okay, so this is shape for calcium. Okay, calcium, but it have, okay, opposite spin, or we call it opposite spin. Opposite spin electron. Okay, so one upward and another one is downward. Okay. Okay, now what is the differences between hydrogen, sodium, and calcium? Okay, if the number of energy level increases, number of energy level increases, so the shape become bigger. Shape become bigger. So the orbital for calcium is bigger than sodium. Sodium is bigger than helium. So size decrease. Okay. So when the number of energy level increase, the size of orbital also increase. Okay. Alright. Now, what is p orbital? Okay, p orbital have dumbbell shape. Have dumbbell shape, and p orbital have three more suborbital. Okay, one, two, three. Okay, because of that, p orbital have maximum number of electron is six. Six maximum electron because it has three suborbital and each orbital have maximum number electron 2. Okay, for each orbital have maximum number electron 2. So for p orbital it has three shape. Okay, first from the x-axis, okay, this is represent one p orbital. Okay, another type of p orbital is from the z axis. Okay, this is also represent one p orbital, and another orbital for p is refer y orbital. Okay, so what is the diagram for p orbital? P orbital have maximum three orbital, right? So it will become as this. Okay. So if the element have three p orbital, the diagram, okay, one, two, three. Okay. Okay. Remember that this is just three orbital. Okay, not six orbital. So this is ps, ps, pz. Sorry, py, pz. Okay. X, y, z. Okay, so this is p orbital. Example, chlorine. Okay, chlorine are located on the p orbital. It have electron configuration 3s2, 3p5. And we draw the orbital diagram for chlorine. And we can see that chlorine have only one single electron. If the atom have one single electron, it just have one p orbital. So this is orbital for p. Okay, this is orbital for p. Okay, okay. If the orbital is 3p, so write down here 3p. Okay, and in orbital just have one single electron. Okay, so another example, oxygen. So oxygen have electron configuration 2s2, 2p4. Okay, and then write down the orbital diagram, and we can see that oxygen has two single electron. So what is the diagram for oxygen? Okay, if oxygen has two single electron, it will have two p orbital. For oxygen, its orbital is okay, one, two. Okay, two p. Okay, all right. This is orbital for oxygen because it have two p orbital. Okay, next nitrogen. Nitrogen has electron configuration 2s2, 2p3. And if we draw the orbital diagram, you can see that nitrogen have three single electron, meaning that it have three p orbital. So draw the orbital for p as for nitrogen. Okay, imagine that this is three dimension. Yes, y, z. Okay, this graph is not necessary. We just have to draw the orbital only. Okay, so this is first p orbital, second p orbital, and third orbital. And then okay, right, symbol the orbital. Okay, 2p, 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 and every orbital have one single electron. Okay, so that's all for introduction. Orbital diagram for atom. Okay, on the next video, I'll explain the hybridization. Thank you.